Even before we start with this example, when we do a dependent sample t-test, what is important? Even before we get to the definition of the test, the first step. Even before the definition, well, by definition, what definition are you referring to, right?
Like what we're trying to find with the test.
Okay, you mean greater than, less than?
Yeah.
Okay, even before that. What is D? What D is? You've got to know what the difference is. I asked for a specific example so that you can understand that this time you could do a left tail test. Last time we did a right tail test because that was the most reasonable test to do. We wanted to know if the money that people gave went up, or willingness to give or donate money went up after watching the art. So an increase after minus before, we want the differences to be positive. The more positive it gets, the more willing people are. This time, the example is on pain. Instead of writing the entire problem, visualize it. So you have a PT program, and you've got patients with ACL tears. How about 10? 10 patients. So patient 1, patient 2, patient 3, patient 10. So they all go into this program, they come out of the program. Now, what do we expect? Let's say, what are we measuring, Olivia?
Their ability to do the exercises, like there were like.
Are they getting better or not?
Yeah.
Okay. If we are going to go with better, then whatever score that I would have here must be higher than there if the intervention worked. Do you agree? So let's not go for the better case. Let's just say pain. Good. Reduction in pain. So we're going to measure reduction in pain. Scale of 1 to 10. Oh, 0 to 10. 0, no pain. 10, extreme pain. I could have gone with what Olivia had and define the difference in a way that I would get negative values. I didn't want to do that because I really wanted to go with an example that sort of tells us, oh, we should probably do a left-hand test, which is why I'm going to go with this. And in every single case, we did after minus before. This case will also be after minus before. Okay, people went in, out, maybe 6 months, maybe 6 weeks, who knows. Before treatment and after treatment, technically speaking, if the intervention, which is the PT program, is effective, what do I expect to happen after?
Reduction in pain.
Reduction in pain. It has to go down. Okay, let's start with 9, 7, 6, 7, 8, So 10 patients, so I've got 10 observations before, after. And before we've got a bunch of values. Patient started with 9, 7, 6, one person said 8. After the program, dropped down to 3. If I define the difference D as after minus before, if the program is effective and I define the difference to be after minus before, what should go in there? If the program is effective and if I define the difference to be after minus before, keyword average difference, because we're not looking at just one person, we are looking at 10 people. The average difference has to be negative. I left a space there. Who can fill that in for me? Necklace, significant. Very good. Want to be a statistician. It has to be significantly negative. That is what we are trying to see. If this intervention, which is our PT program, is it helping? If it does, we would have a significantly negative effect. Okay, how would we define the null and the alternative?
Well, the null would be that mu was is greater than or equal to 0. And the alternative is mu is less than 0.
Olivia, I saw your hand go up.
I was gonna say the same thing, I just don't understand, or I don't remember why the null has to be like equal to, because I thought it had to be significantly negative. Like, basically, like, the average difference has to be more than 0, or like. it has
Greater
to be
than
less
0.
than 0, right?
So that was last time,
Oh,
right? Last time this was less than or equal to. Why was it less than or equal to? We wanted a significantly positive result.
so
So
our
you
wanted result is the alternative?
Always the alternative. You always test for the alternative. I've seen some people, even some undergraduate textbooks, say, oh, we can test for the null too. No. Theoretically speaking, you test for the alternative. The entire decision is based on it's for the alternative using the null as your reference. So Declan knows, I guess, from practice, so he just went for it. If you still have difficulties, you start here, right? What is the question that you're trying to answer? Is the PT program effective? Well, when does it happen? If I define the difference as after minus before, It does if I have a significantly negative effect, which would mean average has to be less than 0. Right, that in the alternative, once you figure this out, the null is simply the opposite. So which is why I always say start with the alternative, go from there. Would it be okay to put D instead of mu? Go on.
No, that would indicate only one, data point difference.
Very good. You can't put D, it has to be mu, because if it is D, you are referring to just one of these values. But statistics does not work by looking at one number. We are looking at a bunch of people. Okay, alpha 0.05. Unless you want a different value. Should we use the different value? Let's use the 0.1. We have the data. Let's just say our assumptions are verified. Assumptions being these participants in the program must be independent of each other, which is true. Just because one person tore their ACL doesn't mean the other one's going to intentionally tear their ACL and end up in the same program. Silly. So clearly the participants are independent, but within a subject, they are related. If I looked at participants named Joe before, I've got to go and ask Joe after. You can't ask a different person. Dependent. What is another assumption?
Normality.
Normality. The data must be normally distributed. In other words, we shouldn't have skew in simple terms. Okay. I think the assumptions are satisfied here. I know that makes sense. Next step is to use the data and find the test statistic. The test statistic is going to help us obtain the conclusion. So, I want you to go ahead and do it using the t-test approach from last time and tell me what the conclusion is. Once you have that, we will do the formulaic approach just as a review for the class.
Yeah.
If you did t-test, I guess I can show it to you now. I have the data entered in my calculator. Many of you got it right. A recurring problem that I saw is interpreting the p-value. Can't stress this enough. P-value is a probability, and probability cannot go above 1, and probability cannot be negative. Either of those happen, it simply means you did something wrong. So I entered all 10 participants' information in my table. List 1 is before, list 2 after, and list 3 after minus before. So all the differences are in the third list. Start over the test. Option number 2. Data. Mu is just 0. We want to, mu naught is just 0. We want to see, is it 0, which means no difference whatsoever? Negative means there is a difference. And our objective is to determine if we have a significantly negative difference, average difference. can't be L1, it has to be L3. And which choice to pick over here? The middle one. Look at the alternative, look at the sign. The sign there is less than, so less than. So second choice, select and select. That is the answer we had. So the test statistic is approximately negative 6.082. As I went around, more than a few, wrote the p-value as 9.16. And what's your name? Yeah, said, Lino, that said, should I go and blame the manufacturer of the calculator? No, you are misinterpreting this number. You're not blaming them. So 0.1608 can't be greater than 1. Something's wrong. What is wrong? You are forgetting to notice that e base -5, which would mean times 10 base -5 scientific notation. So you've got to move the decimal place backwards 0.00000916 with it 90. X bar. What is X bar? Yes. What is it called? Sample mean. It is the average difference that we get from the sample. What is S? It is the standard deviation. Is the standard deviation the same as standard error? No. Absolutely not. Okay, so what letter does the book use for XR? M. Very good. Did the homework. Some haven't got a clue. Did you do that? Okay. So test statistic. You can get it using the calculator, but what if the data is not provided? You need a formula. Do we remember that formula? If not, you've got to put it in your cheat sheet. Riley?
X bar minus mu over the standard error.
Divided by the standard error, not the standard deviation. So that square root of n is important. So we know what that mu value is. We are starting at 0. So if you plug in 0 there, the formula for test statistic would simply be m divided by s over square root of n. Do we know m? Yes. Question?
Oh, nothing.
Do we know s? Yes. Do we know n? Yes. 10. Plug it in, and when you put it in your calculator, make sure you put parentheses. What number do you get?
Just it's just
It's negative 4.1 divided by s 2.0. 132 over square root of 10. Taking
Negative 6.0821.
negative 6.082. Isn't that the same number you have here? Yes. So it depends on the problem. Is the problem giving you this information and asking you to come up with a conclusion? Or is the problem giving you the data and asking you to come up with a conclusion? So value will be the same, negative 6.08. So do we believe that there is evidence to support that this physical therapy program is effective? Riley? Yes, why?
Because the p-value is less than our alpha.
P-value is less than alpha, so that is our standard. Ask yourself this. If you say yes, you reject the no. Otherwise, you do not reject it. If you read the p-value correctly, it is in scientific notation. That number is 0.000092. Alpha that I picked is 0.1. That number less than that number? Absolutely. So, yes. Reject, no. If we reject, going back to the very first day of class, and since then, we are saying that there is a significant effect. In our case, we have a significantly negative average difference. So we defined the average to be, difference to be after minus before. The average difference is less than 0 and it is significant, yes. So if you rearrange this, you will have after, move before to the other side. After is less than before. Our statistical test ended up showing that this is significant. So is the PT program effective? Yes. Is there evidence to support that? Yes. Ask those 10 people. Well, we already did. Good. What is the probability based on the data? I've rejected the null. What are the chances, or what is the probability that I made a mistake, or I'm likely to have made a mistake?
Was it 0.00092?
0.000092. Good. It is simply the p-value. It is the probability of a type 1 error affords positive based on the data. Given all this evidence, I rejected the null. What are the chances that I could be wrong? 92 out of a million. So, can I reject the null? Absolutely, right? I showed you t interval last time. Go ahead and use the same data, use L3 instead of a t-test. Do t interval, which is option number 7, and tell me what the interval is.
5.336. And then negative 2.864.
And what did you use for sea level?
90.
0.9.
Yes,
Why 0.9?
because our alpha is 0.1.
Alpha is 0.1. If alpha is 0.1, the confidence level is 0.9. Yes.
How do we find the critical values here? Or like, is there a formula for that?
Critical value or these?
Yeah, how did
This one,
yeah, how did she find those?
T interval. In under starts, you had T test, that's option 2. Go to option number 7. It's T interval. Is it significantly negative? Well, it is negative. The sample mean is right here. Does 0 fall in that interval? No, not just 0. Any value that is claimed here cannot fall in that interval. 0 doesn't fall in that interval, so we can reject the null.
Does it matter that the test statistic doesn't fall in the interval either? Like, is that useful to know?
So this conclusion is based on a confidence interval, not the test statistic. I'm going to do the test statistic one also. So this result using the test and the test purely. This one using the T interval. Ask yourself, does it contain 0? 0 doesn't fall in leaving a space there for a reason. What should go in the middle? What?
X4.
Okay. Now, Declan says X bar. Do we agree with Declan's answer? Sophie,
I think it's weird.
you think or you know? You think?
I'm very unsure.
You know, it's mu. It can't be X bar. X bar is something you know, right? You're trying to come up with an interval for the unknown quantity, which is mu. Sample mean, I already know that, right? You try to find an interval for the unknown quantity using the mean. The last approach, of course, it should give you the exact same conclusion. Where should the rejection region be? Should it be on the right? Should it be on the left? Declan says left. Why left? Because it's a left-hand test. Look at the alternative. Okay, so that is our negative critical value or the cutoff. How do we find this cutoff? We have to use inverse T. What do you do if you don't have inverse T value? You use the table. I usually give that to you, and even if I forget, you can come up here and use it. So use inverse T. What should you plug in? Is it 0.1 or is it 0.25? In other words, should I put 0.1 as is or divide it by 2 and put 0.5? 0.1. Why should I not divide it? Because it's not a two-term test. So put in 0.1 in inverse T. You'll have another argument, which is df. What is the df in this case? What? N minus 1. So 10 minus 1, which is 9. So what is that number?
-1.9. 0.383.
Negative 1.33. That is my cutoff. Now, where is my test statistic that I got from the data? Is it in the rejection region? Yes or no? Absolutely. 0 is over here, negative 1 is over there. Somewhere over the rainbow, right here. Oh, in the darkness. Negative, what is that button?
0.
In the rejection region, so we reject the null. Good. Of all these two are important. Interpreting using the p-value, interpreting using the interval. That's what's important. If you looked at the homework problems, the questions pretty much were along these lines. Yes, the person did this, got that.